By 2030, 4 years from now, the United Nations projects that 2/3 of the global population will live under water stress conditions. Not water inconvenience, not water inefficiency, water stress. A technical term that means the demand for fresh water exceeds the available supply. And the gap is growing faster than any intervention currently deployed can close it. We already know the shape of this crisis. We have known it for decades. The reports have been written, the conferences have been held, the targets have been set, and the situation has continued to deteriorate anyway. But something changed in the last 3 years that almost none of the mainstream coverage of the water crisis has adequately explained. A set of technologies that previously existed only at laboratory scale or in limited pilot programs have crossed a threshold, driven almost entirely by advances in artificial intelligence, and are now being deployed at meaningful scale in the countries that need them most. Some of them are working. Some of them are creating new problems nobody anticipated, and one of them produced a result so counterintuitive that when I first read the research paper, I read it twice to make sure I had not misunderstood it. 7 countries, 7 crises. The technologies being deployed right now to address them, and the role artificial intelligence played in making all of it possible, and in some cases making it necessary. Here is what I want you to hold in your mind as we go through this video. The water crisis is not a future problem. It is not a problem for the next generation to inherit. It is happening right now in 7 of the most strategically important countries on the planet, at a pace that existing infrastructure, dams, reservoirs, aquifers, desalination plants cannot keep up with. Traditional water infrastructure took a century to build. It is now failing faster than it can be replaced or expanded. So the question is not whether these countries need new solutions. They do. The question is, which of the technologies currently being deployed actually work at the scale and speed the crisis demands? And which ones are creating the illusion of progress while the underlying problem continues to worsen? And the deeper question, the one that connects all 7 countries in this video, is this. Why did it take until 2023 and 2024 for these technologies to reach deployment scale? When the water crisis has been visible and documented for 30 years, the answer, in almost every case, comes back to the same thing. The technologies we are going to cover in this video are not new inventions. Cloud seeding has existed since 1946. Desalination has been commercially viable since the 1960s. Atmospheric water generation, pulling moisture directly from air, has been demonstrated in laboratories since the 1990s. Precision irrigation has been practiced in Israel since the 1970s. Every single one of these technologies has a deployment curve that looks essentially the same. Decades of slow, limited, expensive application. And then a sudden acceleration beginning around 2022 and 2023. What happened in 2022 and 2023? 2 things happened simultaneously that changed the economics of every water technology on this list. First, AI weather prediction models, specifically Google DeepMind's GraphCast and NVIDIA's ForecastNet, achieved forecast accuracy that surpassed traditional physics-based models for the first time in history. For water technology operators, this meant they could predict with unprecedented precision exactly when, where, and how much precipitation was available to work with, days in advance instead of hours. Second, AI-powered materials. Science accelerated the development of next-generation membranes for desalination and atmospheric water capture, reducing energy requirements by 30% to 40% compared to previous technology generations, and cutting costs to levels that made deployment in middle-income countries economically viable for the first time. What AI did was not invent new water technologies. It made existing water technologies cheap enough, accurate enough, and efficient enough to deploy at the scale the crisis actually demands. And it did this just in time, because the 7 countries we are about to cover are not on a slow decline trajectory. They are on curves that, without meaningful intervention in this decade, lead to outcomes that atmospheric scientists, geopolitical analysts, and humanitarian organizations describe using the same word: collapse. Country 1. Saudi Arabia. Saudi Arabia sits on the Arabian Aquifer System, one of the largest fossil water reserves on the planet. Fossil water, water that accumulated over tens of thousands of years during wetter geological periods and does not recharge on any human timescale. Saudi Arabia has been extracting this non-renewable water to grow wheat in the desert, a program launched in the 1980s for food security and now recognized as one of the most aggressive aquifer depletion operations in human history. The technology being deployed, AI-optimized cloud seeding targeting the Asair highlands, combined with a new generation of solar-powered desalination plants using AI-designed graphene oxide membranes that reduce energy consumption by 38% versus previous technology. It is working, partially. The desalination capacity is real. The cloud seeding enhancement is real. But neither technology can replenish a fossil aquifer being drained at 9 times its recharge rate. Saudi Arabia is buying time. How much time depends entirely on how fast it can transition its agricultural sector away from aquifer-dependent production. Country 2. India. India faces the most complex water crisis of any country in this video, because it is not one crisis. It is 4 simultaneous crises: groundwater depletion in the north, erratic monsoons in the center, glacial retreat in the Himalayas threatening river flow, and saltwater intrusion in coastal aquifers in the south. The technology being deployed: AI-powered precision monsoon forecasting, using the same GraphCast architecture developed by DeepMind, combined with cloud seeding trials over Maharashtra and Karnataka, and a national network of atmospheric water generation units targeting rural communities that have lost groundwater access. The counterintuitive result: India's AI monsoon forecasting has improved agricultural water planning enough to reduce irrigation water consumption by an estimated 18% in trial districts, not by providing more water, but by telling farmers with greater precision exactly when the rain will come and how much, allowing them to plant and irrigate accordingly. Less water wasted on preemptive irrigation is, in a crisis, almost as valuable as finding new water. Country 3. Morocco. Morocco's crisis is straightforward and devastating. The snowpack that historically fed its rivers through the dry summer months is disappearing as winter temperatures rise. Rivers that were reliable for centuries are becoming seasonal, or disappearing entirely. The technology being deployed: orographic cloud seeding targeting Atlas Mountain cloud formations, using AI targeting systems that identify the precise window when mountain clouds are most receptive to seeding. A window that, in Moroccan terrain, averages less than 40 minutes per cloud system. Without AI targeting, that window was missed more than it was hit. With it, the hit rate has improved enough to produce measurable snowpack enhancement in trial zones, buying the downstream river systems additional weeks of flow per year, weeks that, for Moroccan farmers, represent entire crop cycles. Country 4. Chile. Chile's Patorca Valley has been the center of one of South America's most visible water conflicts. Illegal water extraction by agricultural corporations, combined with long-term aridification, has left rural communities without drinking water while avocado plantations are irrigated for export. The technology being deployed, and this is the counterintuitive result I mentioned at the beginning, is fog collection. Fog collectors are large mesh nets erected on hillsides in the path of coastal fog. As fog passes through the mesh, Droplets form on the fibers and run down into collection channels. No energy required, no chemicals, no infrastructure beyond the mesh itself. AI's role: optimizing mesh placement, orientation, and porosity using atmospheric modeling of fog density, wind direction, and droplet size distribution, increasing collection efficiency by over 60% compared to non-optimized placement. Fog collection will not solve Chile's water crisis, but in communities where the alternative is no water at all, it is providing something that no other technology currently can: reliable, zero energy, zero cost fresh water from thin air. Literally, from thin air. Country 5. Jordan receives an average of 111 millimeters of rain per year, among the lowest of any country not classified as a desert state. It hosts one of the world's largest refugee populations relative to its size, compounding demand on a water system already running at its limits. The technology being deployed: an AI-managed national water loss reduction system. Not new water sources, reduction of loss from existing ones. Jordan loses an estimated 40% of its treated water to leaks, illegal connections, and distribution system failures before it ever reaches a tap. An AI system monitoring pressure, and saturation, flow, and consumption data across the national distribution network in real time has reduced detected and repaired losses by 22% in pilot districts. Finding and fixing the water that was already there before it disappeared into the ground turned out to be faster and cheaper than any new supply technology. Country 6. Pakistan. Pakistan faces a specific and time-limited crisis. Its rivers are currently running high, fed by accelerating glacial melt. But the glaciers feeding them are disappearing. Within decades, the melt pulse ends, and the rivers drop dramatically. Pakistan is in the paradoxical position of having too much water right now, causing floods, while facing structural water scarcity within a generation. The technology being deployed: AI flood prediction and water storage optimization, using flood events that currently cause destruction to instead recharge managed aquifer systems, banking water underground during high flow periods for extraction during the coming low flow era. Storing today's floods to drink tomorrow is not a new concept. AI optimized siting, timing, and management of recharge operations is. Country 7. The American West. The Colorado River Compact, the legal framework governing water rights for 40 million Americans, was written in 1922 based on flow measurements taken during one of the wettest decades in the river's recorded history. The river has never consistently delivered what the compact promised, and it is delivering less every year. The technology being deployed: AI-optimized cloud seeding over the Sierra Nevada and Colorado Rockies, combined with precision snowpack monitoring using satellite radar systems, targeting the exact elevation bands where additional snowfall produces the greatest downstream river flow per unit of precipitation. The Bureau of Reclamation formalized this as a core strategy in 2025. The results in trial areas show snowpack enhancement of 10% to 15% above baseline, enough to meaningfully extend the flow season of rivers that 7 states depend on. Not a solution, but enough to matter while the harder political work of renegotiating a 100-year-old water compact gets done. Here is what I want to say clearly, before the conclusion, so that nothing I say next is misunderstood. None of the technologies we just covered will solve the global water crisis. Cloud seeding cannot make rain from empty sky. Desalination cannot replace a depleted aquifer. Fog collection cannot supply a city of millions. AI-optimized leak detection cannot conjure water that does not exist in the system. Every technology in this video is, at best, a way to extract more value from water that is already available, or to slow the rate at which the crisis deepens. That is not nothing. In a crisis moving as fast as this one, buying time is genuinely valuable. Reducing the rate of deterioration is genuinely valuable. Finding efficiency in systems that were wasting 40% of what they had, as Jordan was, is genuinely valuable. But the conclusion that surprised me most in researching this video was not about any specific technology. It was about timing. The global investment in water technology, cloud seeding, desalination innovation, atmospheric water generation, precision agriculture, aquifer management, accelerated almost exactly in parallel with the improvement in AI capabilities that made these technologies viable at scale. Not because investors suddenly cared more about water, because AI made the unit economics work for the first time. Cloud seeding without AI targeting is too expensive and too unreliable to justify at national scale. With AI targeting, the cost per additional liter of precipitation drops to levels that government water programs can sustain. Desalination without AI-optimized membrane design requires energy inputs that only the wealthiest Gulf states can afford. With AI-designed membranes, it is economically viable in middle-income countries for the first time. Fog collection without AI-optimized placement captures a fraction of what optimized systems collect. With AI placement, the yield per dollar of infrastructure investment crosses the threshold that makes it worth building. In every case, the limiting factor was not the technology. The limiting factor was the optimization, knowing precisely how, where, and when to deploy it to get results that justify the cost. And that is what AI provided. Not new water, not a solution to a crisis driven by a century of unsustainable extraction and a warming planet that is intensifying every year. Just enough optimization to make the best available tools actually work. In a world running short on easy answers, that might be the most we can ask for right now. The technologies exist. The AI to make them work at scale now exists. What remains is the harder problem, the one no algorithm solves. The political will to deploy them fast enough to matter. That is the last video in our first series on weather modification and the global water crisis. If you watched all 5, thank you. These took a long time to research and get right. If something in this series changed how you think about any of this, share it. That is genuinely the most useful thing anyone watching this can do. New series starts next week. We are going inside the classified history of weather warfare, from Operation Popeye in Vietnam to the programs that nobody has declassified yet. Subscribe so you are there when it goes up.